Hello everyone. Physics is never a difficult subject for a student who is interested, provided he or she has a clear and strong physics teacher. So here I am, Mr. Dharanidhar, your favorite physics teacher in your favorite YouTube channel, Bhautics. So here I am with one more question that was asked in a previous year board examinations in CBSE Class 10 Science examination. This question was also asked for 4 marks. It was a data based question. So they have given some data. See case 1, case 2, case 3. They have given 3 mirrors, mirror A, mirror B and mirror C. The focal length of mirror A is 20 centimeters and focal length of B is 15 centimeters. Focal length of mirror C is 30 centimeters. All these are concave mirrors. And an object is placed at distance of 45 centimeters in front of mirror A. And another object is placed at 30 centimeters in front of B and another object is placed at 20 centimeters in front of C. So this was the given information. Depending upon that given information, they asked 3 questions. First question is, in which of the above cases mirror will form a diminished image? Diminished image. So this is a concave mirror. We know if we want a diminished image, object should be placed beyond C. When object is placed beyond C, then only image will be formed between C and F. Real inverted diminished image will be formed. Correct? So in these 3 cases, first question is, in which of the above cases mirror will form a diminished image? See, object distance 45 centimeters, focal length 20 centimeters. If focal length is 20 centimeters, radius of curvature will be 40 centimeters. Object distance is greater than the radius of curvature, means object is placed somewhere here. So in this case, the mirror will form a diminished image. So the answer will be mirror will form a diminished image in the first case. They ask to justify. How will we justify? This reason only we can take. So in a concave mirror, when object is placed at a distance greater than radius of curvature, image formed will be diminished image. So mirror will form a diminished image in the first case because the object distance is greater than radius of curvature. Second question, give properties of image formed in case 2. In case 2, focal length of the mirror is 15 centimeters, object distance is 30 centimeters. If focal length is 30 centimeters, radius of curvature will be 30 centimeters. Correct? So, object distance is 30 centimeters and radius of curvature is also 30 centimeters. Means from here to here, radius of curvature is also 30 centimeters, object distance is also 30 centimeters. Means object is placed at C. So when object is placed at C, image will be formed at C only. Real, inverted, same size image will be formed. So give properties of image formed in case 2. At case 2, object is placed at center of curvature only. When object is placed at center of curvature, image will be real and inverted. Image will be of same size of the object. Yes, okay. One more question they asked, that is, what is the nature of the image formed by C? Draw a ray diagram to justify your answer. See, let us see first what is the C case. See, what is C case? C1's object distance is 20 centimeters, focal length is 30 centimeters. Object distance is 20 centimeters, focal length is 30 centimeters. Means focal length means from here to here. So from here to here is 30 centimeters, object distance is 20 centimeters only. Means object is placed between F and P. So when the object is placed between F and P, the image characteristics will be virtual, erect and magnified. We all know this, right sir? So now they ask to justify by drawing a ray diagram. Means for this statement they have given 1 mark and for ray diagram they have given 1 more mark. So let us draw the ray diagram now. This ray diagram very important and that can be drawn very simply, but children will face difficulties in drawing this ray diagram. So with the measurements I will give to you how to draw the ray diagram. So first take a straight line of length 10 centimeters. 10 centimeters straight line you take. Mark a point at 5 centimeters also. So this point and this point. This one will be the center of curvature. This one will be focus and this one will be pole. So now you take a compass. take a compass and the radius of curvature should be 10 centimeters only. Approximately, not approximately, exactly you take 10 centimeters. From center of curvature, you mark the compass and you draw the curvature, concave mirror. Okay, right. So, do you make sure that this length is there? See, this length from here to here, it will be around 4 to 5 centimeters only. You make sure, then the diagram will look good. So I drew a curvature. Now this is not going to be our mirror, this will be glass. If you did not give this backside small lines which we consider as red oxide or silver nitrate, it will not be considered as a mirror. So this is very important, this should also be given. So now we should be placing the object between F and P. So in between F and P, there is a precaution to be taken care. That is, if you take object close to focus, image will form out of the paper. That's why you take the object close to pole. If you take the object close to pole, what happens? Image will also be formed close to pole. So this is object O. What do we want? We want 2 light rays, correct? So one light ray I'll take parallel to principal axis. One light ray I'll take parallel to principal axis. Okay. After reflection, how it should pass? After reflection, it should pass through focus. Okay, sir. It is passing through focus. You make sure that these points are not going away. This is this point and this point. Yes, those both are coinciding. So you draw the reflected light ray. Okay. So one more light ray we want. We can take one more light ray through center of curvature like this. Through center of curvature like this we can take. Or else we can take any other light ray also. So I'll take through center of curvature. So this point is coinciding and object this point is also coinciding. Yes, correct. So if a light ray comes through center of curvature, what happens? The reflected light ray will retrace the path. So this one will be the incident light ray. This one will be the reflected light ray for this light ray. So now if you observe, this is one reflected light ray. This is another reflected light ray. They are not meeting at any point. But we want the point of intersection of 2 reflected light rays. That's why what I will do is, I will extend the reflected light rays back side. See, this is one reflected light ray, correct? This is one reflected light ray. I am going to extend this light ray back. See, back. I am going to extend this light ray back like this. One reflected light ray extended back. And this is another reflected light ray. This also I have to extend back. See, I have extended back. So they both met at this point. This point should be named as image. So now let us measure the object height. See how much object height we have? Approximately 1.5 centimeters. You can see it clearly. It is 1.5 centimeters. So how much image height we got? We got around 2 centimeters. Correct? So this is how you draw the ray diagram. If you draw like this, no examiner will find any reason to reduce your marks. Arrow marks will be very important. See, incident light ray arrow mark, reflected light ray arrow mark. Here also incident light ray arrow mark, reflected light ray arrow mark. 4 arrow marks should be definitely present in each and every ray diagram. If you mention 4 arrow marks, then it will be complete. Not like giving 4 arrow marks on the same light ray. No. Light ray is moving in this direction. From here to here, light ray is not changing the direction. So 1 arrow mark sufficient. From here to here, light ray is not changing direction. So 1 arrow mark sufficient. From here to here, light ray is not changing direction. So 1 arrow mark sufficient. Again, it is reflected back. So 1 arrow mark. So 4 arrow marks are definitely required to represent the direction of light rays. So this is how we draw the ray diagrams. Thank you so much. We'll meet in the next video.